take some time. So it's a pleasure to have Frey from ZP today. We'll be talking about the interplay between Cartesi and Eigenlayer. So please.
Yes, okay. I'll be doing a little presentation on Cartesi computations secured by Eigenlayer, providing economic incentive to Cartesi computations with Eigenlayer. That's the premise of today's presentation. I'll first give a little overview of what Eigenlayer is and what it does and how it works for those who don't know. Eigenlayer is a restaking protocol, the first of its kind. What a restaking protocol does is it reuses the stake from another chain. So in this case, it leverages Ethereum stake to secure middleware. The way it does that is when you stake as a validator on Ethereum, you do not have to withdraw the stake to the same address. You're allowed to change the withdrawal address of your stake to any address. So you set it to an eigenpod address, and then Eigenlayer has some sort of guarantees of what it can do with that stake. So what it comes down to is that it's a set of smart contracts handling slashing, staking, restaking, and operators. I'll go into more depth what those entail. And then the main benefits of Eigenlayer for Cartesi would be the increase in security guarantees and allows for experimentation outside of base layer. There's more benefits, but these are the two main ones for Cartesi. Just as a little note, the stake on Ethereum gets monitored by an oracle, and anyone can prove that if the stake on the beacon chain falls below a certain threshold, that's the minimum amount of stake needed in Eigenlayer, then the operator gets slashed. It doesn't participate anymore. So this is a high-level overview of how it works today versus with Eigenlayer. You have the Ethereum, so you have a DApp, which relies on Ethereum and a AVS. And AVS is an active validated system. So it's I'll use AVS and module through as the same word. So if a DApp uses Ethereum and an AVS, its security is dependent on the smallest of trust models. It's a known problem. It costs a lot to get this security guarantee of the AVS up, and that's what Eigenlayer is trying to solve. An AVS could be, for example, an oracle or a data layer. But anyway, with Eigenlayer, the Ethereum stake gets reused, and it then So with Eigenlayer, the stake gets reused, and that then gets used to validate the AVS. So if a lot of stake gets restaked, then the AVS will have a higher trust model than it would have before, especially if the majority of ETH would be restaked, which is a ambitious, but in my opinion, unlikely goal. But then the trust models would be similar in size. So here on the left, you can see this diagram. You have the base layer, Ethereum, you restake your ETH using Eigenlayer, and then the operator opts into securing an AVS. So it's important to note that you do not have to validate every single AVS built on top of Eigenlayer. You can choose to opt in to validate certain middleware versus other middleware. That's a risk to reward balancing exercise each operator has to do for themselves. Each AVS contains a container and a smart contract. So the container does off-chain execution by restakers, and the smart contract does on-chain slashing and payment. And this is going to be important in the future slides, because you can already tell that Cartesi fits nicely into this, or Cartesi compute at least fits nicely into this paradigm. Then how does it work? You have the Ethereum validators who restake, they can become an operator, or you can delegate to an operator. So not every restaker is going to have to validate middleware. You can delegate to an operator who then validates for you. Operators validate AVS, an AVS to their choosing, or multiple AVS to their choosing, and they of course get paid, adding an additional revenue stream to their Ethereum stake. So I think in this environment, that there's a lot of people who want to stake, but they also want maybe an extra revenue stream. That's why you see a lot of these liquid staking protocols to add extra yield on top. And this could be a nice model to achieve that in a somewhat safe manner. Then I'll give you a little, I'll show you the one of the contracts that they give as an example to so it becomes clear how it works. So you have a Eigenlayer middleware example service that / validators that sign a message that when hashed 10 times starts with less than a certain number of zeros. Okay, so we scroll down to the submit signatures. Anyone can call this this function, and it has signers that are certifying that a deca hashed message starts with at least num0 0. So we'll just quickly run through it. You have to make sure that the message isn't already certified. An EOAS to call this function. Then you extract the signers. Use the registry to do this. You have to check that they're active operators, and then you can add your signers. And here you add a dispute period to your claim, and you store it. And then you have the slash function the function of slash signers. This function is called by anyone to slash the signers of an invalid message has been certified. So here it simply just makes a dispute, and it freezes the operators if the dispute is correct, and it certifies this on chain here in this function. So on a high level overview, you have you submit a claim that can then be disputed, and then it gets computed if that's correct, and the signer gets slashed. If it's incorrect, nothing happens. So that was an implementation that they give. So I came up with 2 implementations for a possible Cartesi Eigenlayer overlap. I bet there is more, and I bet you guys can come up with even better implementations, but these are maybe some food for thought. So the first one is an economic layer on top of Cartesi Compute, and the other one is the economic layer embedded into Cartesi Compute. So we have this Cartesi Compute architecture, and as you can see, there's already the compute node claimer and the compute node challenger, and the compute smart contract. So it resembles the architecture of an existing Eigenlayer AVS already. I'll go over how it would be implemented. So the layer on top would be an optimistic layer for Cartesi Compute, which would in turn align incentives downstream to Cartesi. The benefits of this this architecture or this design pattern over the embedded one is that it's simpler, and it doesn't change existing code base. So the existing code base can be reused. The cons is that it adds waiting time, and since there's already waiting time in Cartesi Compute, this could be a big con. This is how the flow would work for such a system. So a user asks for a computation to be computed. An operator posts a computation to a smart contract. A dispute can be started within time window. Then Cartesi Compute verifies the computation. Operators get paid for posting correct computations to this initial smart contract, and operators get slashed if they post incorrect computations. And then, of course, the disputer gets paid for a successful dispute. The incentives align for operators to be running a claim node and slashers to be running a challenger node, but it is not necessary. So you would be inclined and incentivized to run these nodes to make sure the computation actually gets computed, but it's not a prerequisite. And then middleware contract is a new contract calling the Cartesi compute contract, just to make sure that that is clear. So contrary to that, we have the embedded layer. We'd have economic incentives to correctly execute computations. So incentives at every step of the way. So at the inside the Cartesi compute contract, you would add the incentives. The benefit of this would be that you keep the same Cartesi compute interface, which I guess technically could be achieved with the previous one as well. And another benefit would be no added waiting time. A con of this would be added complexity to the Cartesi compute contract. So this is how the flow would work for such a system. It's the user calling existing Cartesi compute API, of course, newly deployed contracts. Cartesi nodes are the operators, or vice versa. Operators get paid for submitting claims. Operators get slashed for, after a successful challenge, and challengers get paid after a successful challenge. So the big difference here is that the incentives are inside of the Cartesi compute contract and not a layer on top. So there's no added waiting time. And here operators have to run claim nodes, slashers have to run challenger nodes, and they would be stored into a register. And the Cartesi compute contract is the middleware contract. So I personally think that a combination of both could be nice, because you could use the layer on top as a training wheel, see what it how it does, if it has any success, and then you could later down the line use the embedded layer as a production version. Then my last point is the why we should do, why this is I'm proposing this. It would add enhanced security. So you would have extra capital securing Cartesi compute. You don't have to fully rely on Eigenlayer, but it would be an added source of capital. Risk management with Eigenlayer's dashboard for the ABS. I found this in the white paper. I'm not sure where this is in production, if they're still working on it, but it is mentioned in the white paper. So potentially for the future, could be really nice to have a dashboard that transparently shows how liquid and how quote unquote safe your module is. Then the last 2 points, the bigger reach. You have the overlap of Eigenlayer and Cartesi people, which might not be that big, or maybe it is, I don't know. But you also reach people who would have been interested in Cartesi but haven't been exposed to it in the Eigenlayer community. So, and the reason that they would or are likely to participate is because it's very early. There's no or very little modules are actually live on mainnet and using Eigenlayer. So it would be a good first mover advantage to use this. That was the presentation.
You were talking a moment ago about a registry. So what does it mean kind of like in Eigenlayer terms?
So the registry just keeps storage for who is the operator, different which tokens can be used as restake, and it just holds all the information about the middleware, what it like who can verify the middleware and what can verify the middleware and all that. I can show it really quickly. So we have the registry base. So we have an operator list used for storing the list of current and past registered operators. We have the total stake history, total operators history. So this registry is used in the middleware contract to access this information.
So this is like the stake essentially, that thing part. So for example, the CC, DSA registry. So for example, the registry of kind of like the keys that these individual nodes are then using.
Yeah, I didn't fully understand your question. Could you please repeat it?
Yeah, so for example, there was this file ECDSA registry. So it's like a registry of the keys that of the individual node in this particular case.
Yes, it has the this is an implementation of the registry base, which I just showed, and it does hold the keys of the operators, and there's also a function that allows a whitelist for operators to join. And currently where Eigenlayer is at is that they have people restaking, but there's no modules, but the people who restaked earlier will get a whitelist to validate certain modules earlier. But yes, to your question, it does hold the operators. If that was your question.
Yes, thank you. I think Daniel raised his hand as well.
Hello, thank you for the presentation, first of all. I wanted to ask you what happens or who is in charge of the stake Ethereum on layer 1, let's say. If Eigenlayer is, or Eigenlayer, I don't know how it's pronounced, but do they have access to those funds and they actually use them as they are deposited, right, in a pool? Are they actually playing the role as validators in layer 1 Ethereum?
Yes, they are actually validating the Ethereum chain alongside validating or delegating to an operator.
So is there any risk on Eigenlayer being malicious for your stake? I mean, you're having your stake delegating into another, then you're using your stake maybe to validate other chains, but you also validate in layer 1. So there's not only one thing only one place to slash from your malicious behavior, let's say.
Yeah, so there is a function that that allows anyone to slash the once a person's account is below a certain threshold of minimum stake needed in the Eigenlayer system. So once you're below that, you get slashed as an operator and you cannot continue validating the ABS.
And who is in charge? Is Eigenlayer in charge of the L1?
No,
because just imagine if we all trust in Eigenlayer for depositing our assets, then he can become like malicious on layer 1. We have no power or any source to change the vote or the chain that, or whatever claim he has done on layer 1, right? So I see that maybe you have more security, but towards centralization.
So wait, I'll just go over what it says on the documentation. Is that if an Ethereum validator restaked on Eigenpot has a balance that falls below required balance way, then they're overcommitted to Eigenlayer, meaning they have less stake on the beacon chain than the amount they have recorded as being restaked in Eigenlayer. Any watcher can prove to Eigenpots that the Eigenpot has a validator that is in such a state by submitting a proof of overcommitted validator balance via the verify overcommitted stake function. If proof verification or other checks succeed, then required balance way will immediately decrement from the Eigenpod's owners, i.e. staked shares in the strategy manager. The existence of an overcommitted validator imposes a negative externality on middlewares that the staker is securing, since these middlewares will effectively overestimate their security. Proving overcommitment provides a mechanism to eject these validators from Eigenlayer to help minimize the amount of times overestimation lasts. Note that the validator with a balance of 0 ETH will be blah, blah, blah. So anyone can call this verify overcommitted stake to make sure that no one is overcommitted. So it's not Eigenlayer in charge of this.
Just one comment, I don't know if that was clear. The people who are validating both, let's say layer 1 and some AVS in Eigenlayer, they should be running both softwares, and they are not you're not trusting that Eigenlayer will do correct block proposals in L1. You do your own block proposals. What could happen instead is that the Eigenlayer slashes your restake. That means when you withdraw from layer 1, you don't withdraw to your wallet, you withdraw to Eigenlayer, and then they will get your money. So it's not like Eigenlayer is going to become a huge node, Ethereum node in the end. You still run your Ethereum node.
Yes, you still run your Ethereum node. It's it's not like a liquid staking protocol. So you run your node and you change the withdraw address to an Eigenpod address, which you then prove to it using the beacon chain route.
So back to the presentation, I think, first of all, thanks for the presentation. There's one thing that it reminded me of, which I think is something we should understand in more depth, which is the similarities between this way to use Eigenlayer and TrueBit. So I don't know if everyone is familiar with TrueBit, but it was one of the first optimistic compute protocols. It was not a rollups, but a compute protocol that was very early. And they had an algorithm to incentivize people to perform computations. So unlike Cartesi, where you have either a validator, or in the case of compute, you have a set of interested parties in that computation, you would say, I want this to be computed, and anyone could go there and drop the result or challenge posted results. Besides the n-by-n concerns that we talked more in previous meetings, there is the concern that you could, if you set up an incentive layer, people would rush to claim, and then who do you pay, right? Are you going to pay the first 10 of them? So there is a problem of kind of a race to claim. And there was the problem that some people may not even be interested in performing the computation. They just repeat the last claim, right? Someone claims the result is 25. So just repeat, yeah, it's 25 just to get the prize, saving the computation effort. So they made an algorithm to avoid this type of pitfalls. So there are several layers on top, and we should check, because I also remember the algorithm being criticized. So we should take back to that literature and see what was the current state, to see if it applies or not to Cartesi compute in this scenario, right? I know that it doesn't apply when there's a fixed set of interested parties, because then it's clear how you incentivize. But if we open it to the public to claim, we should go back to those discussions. Maybe you can have, I could also do a research meeting about TrueBit, and I read that back. It's a good incentive for me to read that again.
Yep.
Yeah, for funny story, me and Freya originally met in the TrueBit token community, so we know a bit about TrueBit as well.
Great. So yeah, if you prefer, you can also we can also have conversations before any presentation to see if I need to catch up with that literature. I don't read it for more than 5 years, and I know some discussions happened in the meantime.
Yeah, it's been some time for me as well.
So why is it that people see Eigenlayer as something very controversial.
No, I don't think people see Eigenlayers as controversial. I remember that some people found the way TrueBit incentivized their validators was controversial.
Yeah, of course. No, but I meant this was a question to Frey about because people are finding restaking very controversial at the moment. Like there's been entire podcasts for this topic. So can you explain a little bit why they see it as kind of like as risky or something like that?
Yeah. So if I remember correctly, there was this article from Vitalik, this blog post that talked in about this, and it was mainly, as far as I know, and followed up on it, about the social consensus. So the actual act of restaking isn't problematic, but it's once people start to expect that if Ethereum is indirectly validating another service and this service gets hacked or this service is faulty, that social consensus would expect the the Ethereum base layer to fork to accommodate those people affected by the hack on the middleware. So as far as I know, that is the main concern around Eigenlayer restaking. Does that make sense?
Yeah, that's a pretty mild concern, right? He just doesn't want other protocols to give opinion on his forking rule.
Yeah. There was a whole blog post on it.
So, well, one thing I noted in the smart contract is that they're talking about freezing operators. So why are they freezing them and not just outright slashing them immediately?
As far as I know, they freeze them until the operator withdraws because they don't have direct access to the funds in the beacon chain.
Right. I think I read something about that they kind of like have let's say a social layer you can also attach to in this regard. That kind of like that if there's a mass slashing because of a hack, like you mentioned, that you would kind of like have the slashing reviewed by a committee of humans essentially if you should actively be slashed. A little bit like if you can get pardoned because it was just that you were getting mass murdered essentially, and basically I think that's why it's kind of like to freeze semantics instead of flashing, because you're removing somebody from operational service, but their state doesn't necessarily disappear until later.
Yep. Yeah, there are some training wheels on Eigenlayer. If I remember correctly, there is a multi-sig with people. I don't fully remember what they have say on, but yeah, the slashing.
So I'll stop the recording, and maybe if someone wants to make questions off record.